Good morning, students. My name is Murli Krishna. Today we are discussing paper 6, black 3, uh, synthetic strategies. Paper 6, black 3, synthetic strategies. Unit is Unit 11. That is introduction and target selection and terminology. Introduction and target selection and terminology. Introduction and target selection and terminology. So we are discussing this topic today. Unit 11, Introduction, Target Selection and Terminology. First discussion, what is synthetic strategy? According to E.J. Corey, it is a problem-solving technique, logical analysis, and which normalize the target molecule into simply readily available starting material. Okay, according to E.J. Corey, it is a experimental, logical, analytical problem solving technique which normally deals with the planning of synthesis of organic molecule from readily available starting materials. Okay, synthetic strategies. So in these synthetic strategies we are discussing some terminology regarding to synthetic strategies. So first terminology is target molecule. Target molecule. So the molecule which is chosen for synthesis in laboratory, or the molecule which is chosen for retrosynthesis analysis is called target molecule. The molecule which are chosen for synthesis in laboratory is called target molecule. For example, I am taken this is the benzoic carboxylic acid. I am taken this is a n propanoic acid. This is a propanoic acid. The propanoic acid I am taken, this is the target molecule I am taken for synthesis in laboratory. How can synthesis means I am taken propanol. Propanol. When this propanol reacting with SOCl2, intramolecular nucleophilic substitution reaction. So hydroxy group is replaced by chlorine. Now when this compound reacting with sodium cyanide in presence of cyanonucleophile, this nucleophile undergo replace the chlorine by loss of sodium chloride. The cyanide will be formation takes place. When this compound undergo hydrolysis then forms carboxylic acid. So this is the one of the way to synthesis of laboratory. The molecule which is synthesized in laboratory is called target molecule. Okay, this is a target molecule. And next one is target molecule. Next one is disconnection. Next one is disconnection. Before this we are going to discussing what is a synthetic strategy. Synthetic strategies means it is a completely reverse of synthesis. It is completely reverse of synthesis. So what is a this is a synthesis. Okay, what is from propanol to propanoic acid is a synthesis. Now reverse is the retrosynthesis or synthetic strategies. Synthetic strategies also reverse also called retrosynthesis. So now I am taken here disconnection. What is disconnection means? The idealized or hypothetically or imaginary breakdown of the covalent bonds in the target molecule or in a reversal of synthesis, that is retrosynthesis, is called disconnection. An imaginary or hypothetically breakaging of covalent bonds in target molecule or in the retrosynthesis is called disconnection. Okay, simple I am taken here best example. Here I am taken is the best example. Here I am taken, so nitrobenzene I am taken here. When this nitrobenzene undergo retrosynthesis, Under retrosynthesis, the bond is imaginary breakage takes place. The bond is imaginary takes place, breakage takes place. So and HNO3 plus H2SO4 will be formation takes place. This is called the breakage disconnection. The bond which is imaginarily or hypothetically breakage in target molecule or in synthesis or retrosynthesis is called disconnection. So simply that is what is target molecule? The molecule which is synthesized in laboratory or the molecule which is used in the retrosynthesis analysis is called target molecule. Here this target molecule, what is nitrobenzene is target molecule which is undergo disconnection. So under retrosynthesis analysis, therefore this target molecule is this nitrobenzene is called target molecule TM. This target molecule undergo disconnection takes place, then produces benzene and HNO3 and H2SO4 is the product. So this is a retrosynthesis. It is exactly reverse to the synthesis. So did retrosynthesis. Next we are going to synthesis. How we can synthesis? When benzene am taken, when benzene reacting with HNO3 and H2SO4 and H2SO4 then produces nitrobenzene. Okay, nitrobenzene. So we are synthesize the target molecule. Okay, what is target molecule? The molecule which is chosen for synthesis in laboratory or the molecule which is chosen for disconnection of the bonds in retrosynthetic analysis is called target molecule. This is target molecule, this is target molecule. So here what is the disconnection? Imaginary breakage or imaginary or hypothetically breakaging of covalent bonds in target molecule in retrosynthesis or synthesis is called disconnection. This is a disconnection. Okay, next we are discussing next terminologies. Synthons. Synthons. So synthons. What is synthons? Synthons are the idealized charge fragments are obtained in disconnection of the covalent bonds in target molecule or in retrosynthetic analysis is called synthons. Synthons are the imaginary and idealized charge fragments. Idealized charge fragments obtained in the disconnection of covalent bonds in the target molecule or in retrosynthesis analysis is called synthons. Best example I am taken again. I am taken here. Nitrobenzene is I am taken. In this nitrobenzene, I am chosen in for the retrosynthetic analysis is called this target molecule. Nitrobenzene I am taken as a uh, target molecule in retrosynthetic analysis. In this retrosynthetic analysis, so the bond will be breakage takes place. Here I am disconnect the bond between carbon and nitrogen. Here carbon is a more electronegative. Therefore, the bond is breakage takes place. So according to I am taken here. NO minus, benzene minus, and nitro is the plus. So these are the charger fragments. These charger fragments are obtained in retrosynthesis analysis is called synthons. So these are negative charge and positive charge. So when we are added negative charge, when we are added proton, then produces benzene. Here I am added HNO3. So these are synthetic equivalents. These are the synthetic equivalents. We are discussing further examples. So what is a synthons? The charged fragments are obtained in the retrosynthetic analysis is called synthons. The charged fragments are obtained in the retrosynthetic analysis is called synthons. Okay. Next, synthetic equivalents.
Yeah, sir, I have a doubt, sir.
Tell me.
Sir, ఈ సింథాన్స్ లో NO2 ప్లస్ ఉంది కదా సార్, బెంజీన్ కి నెగటివ్ చార్జ్ ఎలా ఇచ్చారు సార్?
అంటే మనం దాన్ని సింథసిస్ చేస్తాం కదా, when we are synthesis, so in NO2 plus added, NO2 plus attached on benzene, based on synthesis we are giving the charges.
జనరల్ గా అయితే మాస్
nitration reaction లో when we are taking nitration of benzene. When we are discussing nitration of benzene, so which charge, which fragment, which species attack on benzene? NO2 plus attacking on benzene. Okay, na? Based on that, we are giving the
yes sir, okay.
charges. Based on that, we are giving charges actually. Okay.
So generally
Generally,
okay,
it వస్తుంది, but
so generally the mass spectrum.
Generally mass spectrum.
So NO2 electrolysis చేస్తే NO2 plus
NO2 plus వస్తుంది, but you take nitration of benzene, which species attacking on benzene? NO2 plus.
Yes sir, okay.
దాన్ని బట్టి we are based on the reaction, we are giving the charges. Okay.
Okay sir, okay, thank you.
Now next example, సిద్ధులు. Okay, next example. Next example I am taken acetophenone. When this acetophenone undergo disconnection here, acetophenone under disconnection, so we are disconnect the bond between carbon and benzene, the carbonyl carbon and benzene. When disconnection carbonyl carbon and benzene, when we disconnection here, negative charge, oxygen negative, carbonyl is a positive, here negative. So therefore benzene is the getting a negative charge, and C double bond O, here positive charge. So this is a charge effect. Benzene bearing negative charge and carbonyl bearing positive charge. These are the synthons. Synthons mean so that charged fragments are obtained in the disconnection of the bonds in the target molecule is called synthons. Next, we are going to discussing synthetic equivalents. Synthetic equivalents. So in the synthetic equivalents, these are the substance which can generated in the synthesis. They carry out the function of synthons. So these are the charge fragments. These are the substance. They carry out the function of synthons. Best example I am taken. Same reaction I am taken. Then benzophenone undergo disconnection. Bond disconnection takes place. Here, benzene is a negative charge. Carbonyl is the positive charge. So these are the synthons. When synthetic equivalents, what is synthetic equivalents? These are real substances. They carry out the function of synthons. When I am taken here, the synthetic equivalent of this synthon is phenyl magnesium halide. Okay. So when this for this synthetic equivalent is C double bond O chlorine. Okay. In this case, so here magnesium is a positive, phenyl is a negative. Same. In this case, chlorine is a negative. Here carbonyl is a positive. Same case. Okay, like this one. So when we are synthesis this target molecule, this heterosynthesis. Now synthesis of this target molecule in when phenyl magnesium halide reacting with acyl chloride, they undergo nucleophilic substitution reaction in presence of dry ether is a solvent. So here phenyl is a positive, phenyl magnesium is a positive, phenyl is the negative. This negative substance attack at the carbonyl carbon, chlorine is elimination takes place, then produces phenyl C double bond O methyl. Acetophenone is the formation. This is the synthetic equivalence. This is the synthetic equivalence. What is synthetic equivalence? So synthetic equivalents are real substance which can carry out the function of synthon. Okay. So based on this synthetic equivalents, synthons are the two types are there, positive synthons and negative synthons. So I am given some examples here. So these are the synthons and synthetic equivalents. So these some of the positive synthons, some of the negative synthons. So here taken am synthon of R plus. This is the synthetic equivalent is Rx. When the bond breakage in between Rx, X is a minus, R is a positive. Like this is a synthon and this is synthetic equivalent. NO2, we are discussing previously, NO2, nitration of benzene nitration reaction. So this NO2 is the synthon and synthetic equivalent is fuming in HNO2 or HNO3 and H2SO4. So here previously I'm discussing acyl chloride. Acyl carbocation is a synthon. If acyl carbocation synthon, we are taking synthetic equivalent if is what is acyl chloride and AlCl3. When we using this acyl chloride and AlCl3, we are getting acyl carbocation. Here I am taken hydroxy group attached to carbon, getting if the positive charge of the hydroxy group attached to carbon is the synthon, synthetic equivalent is this is a synthetic equivalent. So how the formation of synthetic synthon for that means, so for in this case, this is a synthon and this is synthetic equivalent. How we are getting synthon means when we take a carbonyl compound reacting with in presence of acid medium, the proton attacking at carbonyl oxygen, then oxygen getting positive charge and oxygen getting positive. For neutralization of this positive charge, the pi bond shifting towards oxygen side, then then O H R, here this is a positive charge. Like this is a synthon and this is a synthetic equivalent. Here also the carbonyl adjacent carbon is the carbon adjacent carbon is the positive charge. When the synthetic equivalent is X. If here so carbonyl beta position is the synthon and synthetic equivalent. We are adding negative part here, positive part. We are adding negative part here, positive part. That we are adding negative part. Or we taken so alpha beta unsaturated carbonyl carbon also we are taking. Okay, because it is undergo shifting ketone and tautomerism. Then here positive charge, here negative charge shifting here like this one. So in this case, if you are negative charge, so we are adding proton. When we are negative charge, we are adding positive. This a proton is a positive, and that in presence of base. So reverse here that hydroxy group beta carbon, hydroxy group beta carbon positive charge. If hydroxy group attached to carbon beta, hydroxy group attached to beta carbon is positive charge. This is alpha, this is beta, beta charge. Then epoxide is we are taken as a synthetic equivalents. Okay, in synthon's case, hydroxy group attached to carbon adjacent carbon is a positive charge. We are taken epoxy is a synthetic equivalents. Simply here. Previously I'm taken benzene is the, if benzene is a negative charge, so synthetic equivalent is magnesium bromide is a synthetic equivalent. Here also negative charge magnesium halide we are taken, Cl minus is we are taken Cl2 AlCl3 like this one. So nothing but if synthon is a positive charge, maximum we are attached to negative charge part. Okay, synthetic synthons are negative charge, positive charge were added a negative part. Okay, if the negative part synthon is a negative part were added positive parts like the magnesium bromide like this one. So based on that we can write the synthons and synthetic equivalents. In exam there is chance to ask you write the synthetic equivalents for the following synthons. In exam previously they ask you in your examination previous compulsory one question from this today class, whatever we are discussing, compulsory one question from this terminology and target selection, compulsory one question we are expecting from this unit. So maximum we are getting question. That is one example. The maximum they ask you question. Write the synthetic equivalent for the following synthons. They asking you. Just you based on that you can write the answer. Then simply for positive charge you can add negative part. For negative part we can add positive part. That is a best way to write the synthons to synthetic equivalent. So in your notes also some examples are there. So you can choose. You can also refer that examples. So one example here, one I'm given. This is a carbonyl attached. This is a previous question, very important. When carbonyl attached carbonyl carbon negative charge. If the carbonyl carbon is a negative charge, synthetic equivalent is the that this is the cyclo dithiene anion acyl equivalent. Dithiene anion acyl equivalent is the synthetic equivalent. Okay. So these are Syntan and synthetic equivalent. This is a previous question. So previously asking. So negative charge, we are getting like this. And simply here, when we take in, how does synthesis means when we take in here, this is a negative carbonyl is a negative part. When we reacting with the dithiene, simple loss of water molecule. Just I am representing you. Negative part like this only. This is Syntan and synthetic equivalent. Next one is
So what is the page number of the equation, sir?
next one is strategic bonds.
The page number of that equation, the previous equation.
What? Previous?
Previous equation page number, sir, in the textbook.
Oh, textbook in page number 196. 196.
Okay.
Page number is 196.
Okay, sir. Thank you.
Next we are discussing transform. Next we are discussing transform. Next we are discussing transform.
Yes. So many. No. Big. Rosen Nirvana.
Transform, it is an exact transform. Simply we are TF, we are discussing. Transform, it is exactly reverse to the synthetic reaction. It is exactly reverse to the synthetic reaction. If I am given you, yeah, this is a phenyl acetophenone. When we are taking acetophenone, when undergo disconnection, phenyl minus and C double bond O positive charge. Okay, this is called when we taken this is called transform. It is exactly reverse to the reaction. It is exactly reverse to the reaction. So this a transform is the represent the reverse of the general normal reaction. Okay, when we taken previously I'm taken nitrobenzene. So nitrobenzene. So when we given here nitrobenzene is the product. Okay, this is called transform, nitration transform. We are called nitration transform. We are called nitration transform. Okay, transform is a simple represent the reverse of the reaction. So that means retrosynthesis, and we are giving the naming of the transform. Naming of the reaction means based on transform. It is a nitration. Reverse reaction is a nitration. Therefore, transform indicates reverse. Transform indicates reverse. Nitration is a reaction. Transform indicates reverse. They have nitration reaction. If I am taken another example,
TV
this is a target molecule. In this target molecule undergo retrosynthesis like this. So diene and dienophile. Okay, this is a which reaction? Diels order. This is a Diels order transform. Okay, Diels order transform. It is exactly a reverse reaction, reverse to the normal reaction. We are representing the transform representing the double arrow mark, giving the naming for general reaction name, then followed by transform. Giving the naming way of the naming is general reaction followed by transform. Okay, the synthesis is benzene reacting with HNO3 and H2SO4. We are getting nitrobenzene. Okay, so this is a nitration reaction. So transform reaction is retrosynthesis, nitration, transform. Okay, Diels order. This is a reverse of Diels order. Therefore, Diels order transform. Okay, this is a transform we are giving like this one. Next one is retron. Next one is retron. Retron. So retron is the subunit of molecule which is keep for disconnection in
తప్పు పని
retrosynthetic.
చేయమని మాడిపోతుంది రా దోస్త్.
Retron, subunit of molecule which is keep for disconnection in retrosynthetic analysis or disconnection is called retron. Subunit of molecule which is keep for disconnection in retrosynthetic analysis or disconnection is called retron. See, I am taking it as a molecule. I am taking it as a molecule here. In this molecule, undergo disconnection. If the molecule will be disconnected like this. So in this molecule, only this part undergo disconnection takes place. Only this part is undergo disconnection takes place. Therefore, this part is called retron. Okay, retron means the subunit of molecule which is keep for disconnection in retrosynthesis analysis or disconnection is called retrosynthesis. Okay, next one is. So these are the terminology in your syllabus. So what are the retrosynthesis and disconnection, synthon, synthetic equivalent, and target molecule, and retron is the these are the syllabus in terminology in your syllabus. Next one is criteria for selection of target molecule. Next one is criteria for selection of target molecule. Criteria for selection of target molecule. Next one is criteria for selection of target molecule. TM. Criteria for selection of target molecule. Okay. There are the EJ Corey recognize the 5 different criteria for the selection of target molecules. EJ Corey recognize the 5 criteria for selection of the target molecule. One is structural verification. Second one is biological activity. Third one is analog studies. Fourth one is topological studies. Fifth one is development of new reagent reactions. First, we are discussing structural verification. First one is structural verification. So in this structural verification, some of the molecules are proposed their structure incompleting. Such type of compounds are selected as a target molecule to complete the structure synthesis. Okay, so structure verification means some of the molecules are proposed incompletely. To such molecules can select as a target molecule for the complete structure synthesis. For example, I'm taken periplanon B. I'm taken periplanon B. This is a structure of periplanon B. Sorry, periplanon B. So this is a periplanon B. In this periplanon B, so these are the chiral centers. 1, 2, 3, 4 is the chiral centers. 4 chiral centers. 2 into 4 is equal to 16 stereoisomers are possible. So 16 stereoisomers are possible. This is periplanon B. Periplanon B. So this periplanon B is a hormone which is released by American cockroaches. That is a Periplaneta americana. This is a hormone. Periplanon is a hormone which is released by the American cockroach. That is a Periplaneta americana. This cockroach. So these so 75,000 of cockroaches. 75,000 of cockroaches. They releases 200 micrograms. 200 micrograms are the given. This much of the compound. This much of the compound is difficult to study the structure of the molecule. Therefore, this type of the compounds are taken as a target molecule to develop the complete structure. Okay, this is a criteria for selection of the target molecule. Okay, first one is criteria for selection of target molecule is first one structural verification. So this is the periplanon B is the structure. This is the molecule. This hormone. It is secreted by released by American cockroaches. 75,000 cockroaches. They releases this much of this very little amount of the hormonal releases, but we need to develop bulkly. So to biology for good biological activity, so we need to complete structure. To therefore this type of the compounds are taken as a target molecule to develop the complete structure. This is a one example for the first one is a structural verification. Second one is biological activity. Next one is biological activity. Next one is biological activity. So there are several natural products are good biological activity, but their yield are very poor. So some natural products are shows good biological activity, but their availability is very less. So such type of the compounds are taken as a target molecule to improve the yield. To improve the yield. Best example are prostaglandins. Best example are prostaglandins. Prostaglandins are the hormone. Prostaglandins are the hormones. Prostaglandins are hormones. So they releases 1 to micrograms in 24 hours. In 24 hours, one or 2 micrograms in 24 hours. So they are shows very good biological activity. Therefore, this type of the molecules are taken as a target molecule to develop the bulk production. To develop the bulk production. Therefore, these molecules are taken as a target molecule. Okay. this biological this prostaglandins shows good biological activity, but the percentage of yield is very less. That with 24 hours they releases 1 or 2 milligrams. So therefore we are taking as the prostaglandin target molecule to increase the biological activity. So this is the biological activity. Next one is third one is analog studies. Analog studies. So analog studies means same structure but small changes. Same structure but small changes are called analogs. Analogs means the molecule is same but substitutions are different. The molecule core moiety is same but substitutions are different. That type of the molecules are called analog molecules. So analogs. Best example for analogs. So penicillin analogs are amoxicillin and ampicillin. Penicillin analogs are amoxicillin and ampicillin. Penicillin analogs. Analogs are amoxicillin, amoxicillin and ampicillin. Amoxicillin and ampicillin. These are the analogs. This is a penicillin. Penicillin is a good antibiotic, but penicillin is somebody కొందరికి penicillin పడుతుంది కొందరికి పడదు కదా. So therefore penicillin not suitable for all the peoples. Somebody peoples are accept their body accepted, some people's body is not accept the penicillin. Therefore this type of condition they develop a new analogs that is called amoxicillin and ampicillin. This is suitable for all peoples. Amoxicillin and ampicillin are suitable for all peoples, and these amoxicillin and ampicillin are shows good biological activity than that of penicillin. Okay, therefore this type of the molecules are just taken as a analog studies. Next one is topological studies. Topological studies. So topology means study of shape structure of the molecule is called topology. Study of the structure of the molecule is called topology. So therefore here, so two molecules are I'm given here, cubene next dodecahedrine. The dodecahedrine. This is dodecahedrine. Okay. So topological studies means some of the molecules are complex molecules like cubane and dodecahedrine. These molecules are shows good biological activity. So such type of cases, these complex molecules which shows good biological activity, molecules are taken as a target molecule. These molecules then convert into simple molecule and increasing the biological activity. Therefore this type of the molecules are also taken as a target molecule. This is the under category of topological studies. Last one is last one is development of new reagent and new reaction. Development of new reaction, new reaction. new reaction and reagent. Development of new reaction and new reagent. Development of new reaction and new reagent. Woodward and Emil Fischer in the synthesis of vitamin B12. In the synthesis of vitamin B12. In the synthesis of vitamin B12, Woodward and Emil Fischer, they're getting a crucial step. They're facing a crucial step. In this crucial step, there is a hydrolysis of, there is a cleavaging of there is a cleavaging of CO bond in the presence of nitrogen. CO bond in the presence of nitrogen. So best example I am given here, that Emil Fischer and Woodward developed a new reagent that is alpha chloro nitronium. Alpha chloronitronium. This is also called vinyl nitrone. Alpha chloronitronium. It is called vinyl nitrone. This vinyl nitrone, in presence of silver catalyst, in the presence of silver catalyst, then undergo loss of silver chloride, then produces here. Then produces vinyl nitronium ion. This is a vinyl nitrone. This is a vinyl nitronium ion is the product. So this is a selective hydrolysis of amide in presence of ester. These two vinyl nitronium or vinyl nitrone are used for the selective hydrolysis of amides. Selectively hydrolysis of amides in presence of esters. Okay, so this is a new reagent which is developed by the Woodward and Emil Fischer in the hydrolysis of selective hydrolysis of amides in presence of ester. This is a vinyl nitrone or vinyl nitronium ion. These two are the useful for the selective hydrolysis of amides in presence of esters. So these are the five are the criteria for the selection of the target molecule. One is the structural verification. Second one is a biological activity. Third one is analog studies. Fourth one is topological studies. Fifth one is new development of new reagent and or reaction. So this is the five are the criteria for selection of the target molecules. Next one is functional group interconversion. Next one is functional group interconversion. Next one is functional group interconversion. Functional group interconversion. Functional group interconversion. Functional group interconversion. It is a reaction which in this reaction conversion of functional group from one form to another form. Conversion of functional group from one form to another form. That is a function group interconversion. Conversion of functional group from one form to another form. Simply I am taken toluene. I am taken toluene. In this toluene undergo nitration. When toluene undergo nitration, so nitration nitrotoluene will be formation takes place. This nitrotoluene undergo reduction in presence of radical hydrogen. That nitro is converted into amine. That nitro is converted into amine. This is also this is a function group interconversion. Conversion of function group from one form to another form. Your nitro function is converted into amine function. This is a function group interconversion. Next one is I am taking hydroxy here. Hydroxy group reacting with SOCl2. Okay, hydroxy is converted into chloro function here. This chloro is reacting with sodium cyanide, converted to chlorine is converted to cyano. This cyano function, and cyano function undergo hydrolysis, then forms carboxylic acid. Okay, so these are the hydroxy is converted to chlorine, one function, chlorine is converted to cyano, one function, cyano is converted into this carboxylic acid. This is a function group interconversion. Function group interconversion. Function group interconversion. Next one is functionalization. Next one is functionalization. Functionalization means introducing a function group is called functionalization. Introducing a functional group is called functionalization. Introducing a functional group is called functionalization. Same here I am taken when benzene reacting with HNO3 and H2S4 nitration, nitro function group is introducing takes place. This is called functionalization. Function group is introduction takes place. This is a functionalization. I am taking indole. If I am taken indole, when indole reacting with formylation DMF plus POCl3, DMF POCl3 will smear Hock reaction. This DMF POCl3 and indole third position is the active position. Therefore, electrophilic substitution reaction takes place at third position of indole. Indole 3 carboxylaldehyde will be formation takes place. So this is a functionalization. If I am taken toluene, when this toluene undergo acylation, toluene undergo acylation, acyl chloride with AlCl3. So para position is a more major. So therefore CH3 C double bond O CH3 acylation at third position in toluene. So here also function group introduction takes place. Function group introduction takes place. Here also function group introduction takes place in the target molecule. That is a functionalization means introducing of function group in a target molecule is called functionalization. Introducing a function group on target molecule is called functionalization.
Sir. Hello.
Next one is retrosynthetic analysis of phenyl acetic acid. Retrosynthetic analysis of phenyl.
Sir. Yeah, ఈ టోలిన్కి ఎసైలేషన్ చేసిరు కదా సార్. పారా పొజిషన్ ఎసైల్ గ్రూప్ ఎందుకు ఆర్థో పొజిషన్ పెట్టొచ్చు కదా సార్, రాయొచ్చు కదా.
నేను మేజర్ అని చెప్పిన కదా, దిస్ ఇస్ మేజర్. ఐఎమ్ టెలింగ్ ఆల్రెడీ మేజర్. ఎందుకంటే హియర్ స్టెరిక్ లోడింగ్ ఇస్ దేర్, మనం వీఆర్ కన్సిడర్ మేజర్. ఓకేనా? సో మేజర్ స్టెరిక్ లోడింగ్ ఇస్ దేర్, therefore major will be formation text. That's why I'm writing your major. Okay.
Okay, thank you.
Next one is retrosynthetic analysis of phenyl acetic acid. సిద్ధులు
సార్ సైదులు సార్. ఓకే
సార్. Sorry. After you can please call me once. Okay, I will send you last notes also. Okay.
ఓకే సార్, థ్యాంక్ యూ.
ఒక్కసారి
ఓకే సార్. ఓకే.
Retrosynthetic analysis of phenyl acetic acid. phenyl acetic acid. Phenyl acetic acid, retrosynthetic analysis of phenyl acetic acid. So phenyl CH2 C double bond O OH. This is a phenyl acetic acid retrosynthetic analysis. When this retrosynthetic analysis, phenyl acetic acid. So what is retrosynthetic analysis? Retrosynthetic analysis is a problem solving technique which is converted into starting material to which is converted into readily available starting material. Retrosynthetic analysis is a problem solving technique which is converted into target molecule into readily available cheaper starting material. So when I am taken for the synthesis of phenyl acetic acid, when it is undergo retrosynthetic analysis, the molecule which is taken as target molecule in the disconnection of target molecule in the disconnection target molecule retrosynthetic analysis, this molecule undergo disconnection takes place. First I am disconnected here, this bond will be disconnection takes place here, negative positive negative. If I am disconnection, we are getting first synthons, we are getting okay, negative charge and C double bond O H positive charge. For example, we are getting like this only. These synthons, these are the synthons. Synthetic equivalent for this one is I am writing CH2, positive part is there, I am writing negative positive, I am writing positive part. For this here, the synthetic equivalent is cyano I am taking. NaCl is I am taken synthetic equivalent. Okay, synthetic equivalent. These are the synthetic equivalent. Okay, so this is synthetic equivalent. So for synthesis of this, target molecule from benzyl halide reacting with sodium cyanide first. So this synthesis first loss of NaX, first loss of NaX, then forms benzyl cyanide. Benzyl cyanide. This benzyl cyanide under hydrolysis we are getting phenyl acetic acid. This is a target molecule. Okay, so these are readily available material. So this is target molecule. The target retrosynthetic analysis means the breakdown of the small molecule in small molecules that is readily available starting material is called retrosynthetic analysis. That target molecule which is the molecule which is chosen for the retrosynthetic analysis is called target molecule. In the target molecule, the bonds are undergo imaginary breakage takes place, then produces the imaginary breakage takes place. This is called disconnection. After disconnection, we are getting charged fragments. These charged fragments are synthons. So synthons, these synthons are ready available in the form of synthetic equivalents. Synthons are available in the form of synthetic equivalents. So once again, I'm explaining you all the terminologies in this reaction only. All the terminologies in this reaction. So what is the retrosynthetic analysis means? The bulk molecule are breakdown into small molecules that is readily available starting material is called retrosynthesis. Okay, these are this total process retrosynthesis. We are representing the bonds in this retrosynthesis. In the retrosynthesis, we are representing the bonds in the double arrow. That the molecule undergo disconnected. The molecule undergo disconnected in this retrosynthetic analysis called target molecule. In this target molecule, the bonds are undergo breakage takes place. This breakage is called disconnection. After disconnection, we are getting charged fragments. These charged fragments are called synthons. These synthons are available in the form of synthetic equivalents. So these are the all terminologies are explained here only in one reaction. Next one is different strategies for retrosynthetic analysis. Different strategies for retrosynthetic analysis. Different for retrosynthetic analysis. Different strategies for retrosynthetic analysis. So one is transform based strategies. Transform based strategies. These strategies are based on identification of powerful transform for a specific target, which gives maximum simplification. Different transforms can be repeatedly applied to results in maximum specification in the retrosynthetic disconnections. So I'm taken here one target molecule. In this molecule, this is that. So when this compound here 1, 2, 3, 4, 5. 1,5 dicarbonyl compound. This is a 1,5 dicarbonyl compound. In this 1,5 dicarbonyl compound, always we disconnect the alpha beta bond. 1,5 dicarbonyl compound. 1,5 dicarbonyl compound. We disconnect the alpha beta bond will be disconnected. Alpha beta bond will be disconnected. Okay, alpha beta bond only disconnect. This alpha beta bond will be disconnection takes place. Therefore here negative positive negative negative charge will be formation takes place. Here positive will be formation takes place. Therefore I'm writing like this: CH3 and C double bond O, CH3 is I am taken. Okay, these are readily available starting materials. So for this from synthesis of this compound is I am explaining here. For synthesis of this compound, when I am taken reacting with the base abstract the proton from here, then C double bond O, CH2 negative charge. Here negative is then again this is negative. That means this is a synthetic equivalent. Okay, this synthon. This negative charge attack it here. This negative charge attack it alpha beta unsaturated carbonyl compounds, because it is undergo it is undergo ketone tautomerism. Here positive charge. Here positive charge. Okay, this is therefore like this only. Now it is undergo ketone tautomerism, then forms CH3 in the target molecule be synthesized. This is a transform based strategies. Next one is structural goal strategies. Structural goal strategies. Next one is structural goal strategies. Structural goal strategies. Their strategies depends on the identification of the potential strategic material, building blocks, and retrosynthetic subunits. Okay, based that is a structural goal strategies means based on structure we are disconnect the bonds. Based on structure we disconnect the bond. The structural goal mighty is this molecule. When this bond target molecule undergo disconnection, this target molecule undergo disconnection, your disconnection takes place like this, and also here like this. Ammonias. So the products are ammonia, and chlorine plus ammonia plus halogen, nitrogen. That means this part will be disconnection takes place, and these are the ammonia moieties, and this is this moiety, and this is this moiety. So we are taken 3 moles of ammonia, 2 moles of ammonia, and 2 moles of ammonia, and 2 moles of this dihalo compound, and this part and this part. This is the structural goal strategies. Next one is topological strategies. Topological strategies. Topological strategies. Topological strategies means complex molecules are taken as a strategic molecule, undergo disconnection takes place. So here I am taking the complex molecule. So this cis molecule, so this is a target complex molecule, because all cis moieties are there, very complex molecule. This complex molecule is taken as target molecule. Therefore, disconnection takes place. We are choosing in the laboratory. Next, stereochemical strategies. Stereochemical strategies. Stereochemical strategies. Stereochemical strategies are mainly aimed at the reduction of stereochemical complexity in the molecule. Okay, reduction of stereochemical complexity in the molecule means, so we are we remove the complexity in the molecule. Just I am taking best example here. I am taking OH and epoxy. So epoxide is a stereochemical moiety because 3-membered ring highly unstable and having one oxygen atom, it is highly unstable molecule. So this type of molecule we are taken as a stereochemical strategies. Stereochemical strategies. So stereochemical strategies. Next one is functional group oriented strategies. Fifth one is functional group oriented strategies. Function group oriented strategies. These strategies utilize the role of various functional groups, interconversion, addition, and removal method for the retrosynthetic analysis in the target molecule. This method, this strategy is useful for the role of various function group interconversion, addition, and removal of methods in retrosynthetic analysis in a target molecule. So best example I am given, one example I am given here. Ester and amine. This compound first it undergo in functional group interconversion. Ester is converted to acid. Ester is converted to acid. Function group interconversion. Next one here also function group interconversion. Amine is converted to nitro. Amine is converted to nitro. Again function group interconversion. Carboxylic acid is converted to CH3. And next one is function group elimination. One nitro is elimination takes place. So this is a functional group orientational strategies. Okay, that means so these are function group elimination followed by function group interconversion will be takes place. Okay, so how does synthesis means toluene undergo nitration, nitrotoluene will be formation. This nitrotoluene undergo oxidation with K-4. That toluene CH3 is converted to carboxylic acid. This now next one is reduction with running nickel hydrogen, the nitrogen reduction takes place into amine, and that carboxylic acid is converted into esters in presence of ethanol and HCl. Okay, so this is a functional group oriented strategies. So this is a today topic, that is a that is the introduction and target selection and terminology in the synthetic strategies. So okay, thank you.